A high jumper runs toward a bar that seems impossibly high. For a moment, the athlete is still on the ground. Then one foot strikes the track, the body rises, turns, bends backward, and floats over the bar. The strange part is this: the body clears the bar, but the body's center of mass may pass below it. That is the hidden physics behind the modern high jump. Older high jump styles looked more direct. Athletes used the scissors jump, the western roll, or the straddle technique. They tried to carry the whole body over the bar in a more upright or side-facing position. Then came the back-first technique, now known as the Fosbury flop. At first, it looked almost absurd. The athlete approached in a curve, jumped from one foot, turned the back toward the bar, arched the spine, and landed shoulders first on the mat. But it worked because it solved a basic mechanical problem. When any object leaves the ground, its center of mass follows a path determined by takeoff speed, direction, and gravity. After takeoff, the athlete cannot simply decide to fly higher. The center of mass is already following its projectile path. So the real question is not only how high the body can rise, it is how the body can be arranged around that rising center of mass. In the Fosbury flop, the athlete bends the body into an arch. The head and shoulders clear first. Then the hips rise. Then the legs are kicked upward and over. Because the body is curved, the center of mass does not have to stay inside the body itself. It can lie in empty space beneath the arched torso. That means the jumper can clear a higher bar without lifting the center of mass equally high. This is not cheating gravity. It is using geometry against gravity. The curved approach also matters. By running on a curve, the athlete creates rotation before takeoff. That rotation helps turn the body sideways and backward in the air. The takeoff leg pushes against the ground, producing an upward force larger than body weight for a brief instant. That impulse redirects horizontal speed into vertical motion, but the takeoff must be precise. Too much horizontal speed and the athlete crashes into the bar. Too little and there is not enough upward motion. Too little rotation and the body cannot turn. Too much rotation and the athlete loses control. The modern high jump is therefore not just a leap. It is a timed conversion of speed, force, rotation, and body shape. The common misconception is that the Fosbury flop works because athletes simply jump backward. The better explanation is sharper. They use a backward arch to lower the path required for the center of mass, while using a curved run and one-foot takeoff to create the rotation needed to clear the bar. The athlete rises. The body folds around an invisible point, and for one brief moment, the most important part of the jump is not the body above the bar. It is the empty space below it.